Hello, everybody. So over the next couple weeks, we're going to start our next big topic, which is looking at quadratic equations or quadratic relations. Last year, you spent a lot of time looking at linear equations, right? Y equals mx plus b. And that allows you to model a number of different situations, when you have something changing at the same rate. Um, the next equation we're looking at is just a different function. It looks like a different type of graph. It acts in a bit of a different way. And what we're doing is building up this toolbox of different equations that we have, and that allows us to model different situations. So we'll probably spend at least the next month looking at this quadratic equation. And it's just a different type of graph, different type of equation. All right, so there is one new term we have to look at here, which is called the degree of a function. All right, so the degree is just the highest exponent on the x term. So if I have an equation and it has an x squared in it, x to the power of 2, we would say it's a degree 2 equation. If my equation has x to the 3, we call it a degree 3. And for our linear equations, there's just an x, and there is still an exponent on it. It's just an exponent of 1. So we say that's a degree 1 equation. It's just a different way of describing the function. Linears were degree 1. Now we're looking at quadratics, which would be a degree 2 equation. Sometimes your equation involves terms that are multiplying together. So for example, maybe something like this. And in this case, those two brackets are multiplying together there. But in this case, if you expanded it out into standard form, you'd still get an x squared. X to the 2 would still be a degree 2 equation. So you always have to expand it out first and then look for that highest exponent. All right, so let's look at this first one over here. So I'm given this equation. We want to go through and make a table of values and then graph it out. You kind of see what it looks like here already, but we'll go through and do that right now. So I'm going to go through, plug in the different x values that I have, figure out my table of values, and then that will allow me to graph it. So first thing I'm going to do, plug in an x equals -3. All right, so I substitute that into my equation. X becomes -3. -3 squared, negative gives me positive. So I can start to fill in my table here. When I plugged in x is -3, I got back y is 9. And that gave me 1 point on my graph. So I'm over here at -3 and 9. I've plotted that point on my graph. And I'll keep going here. Now I'll plug in x is -2. All right, so I have a -2 squared now. Positive 4. Right, give me another point on my graph. -2 and 4. There we go. And I'm going to keep repeating that. We did the same thing with linear equations, right? You can do this idea where you're plugging in an equation, you're substituting each x value, getting back the y value. This works for any equation. We're just doing it with quadratics now. So I'll plug in my -1 now, -1 squared, +1. Give me another point, 0 squared, 1 squared, 2 squared, 4, 3 squared, 9. I've now created my table of values. I plotted out each one of those points, and now we see what a quadratic equation looks like. It's this U-shaped graph. If you're modeling something, it's going to be something that decreases and then increases again in this case. All right, so what else can we do with that? Well, when we looked at linear equations, we always calculated first differences, right? What was the rate of change? How much did it change each time we moved over? So let's do the same thing with quadratics and see what we end up with here. So remember, for your first differences, you always subtracted from the bottom upwards. So we'll do the same thing here. 9 minus 4, 5. 4 minus 1, 3. 1 minus 0. Always go from the bottom up. 0 minus 1, -1. 1 minus 4, -3. 4 minus 9, -5. Okay, my first differences are not the same. So that tells me the rate of change is not always the same. The slope is not always the same. It's obvious from the graph here and from my first differences now, I've seen that it is not a linear equation. So if those first differences are not all the same, you know it's not linear. And if you graphed it out, you could see it from that as well. But if you didn't have a graph, you could just calculate your first differences. And if you're getting different numbers, you know it's not linear. Now, here's the new thing. What you can do is you can look at how those first differences are changing. So you're going to do the exact same thing again, subtracting upwards from the bottom. We call those the second differences. 5 minus 3, 2, 3 minus 1, 2, 1 minus negative 1 turns into a 1 plus 1. Negative 1 minus negative 3. Negative 1 plus 3. And so forth. Okay, second differences are all the same. That tells me something. That tells me that it's a quadratic equation. So if your second differences are the same, you know it's a quadratic equation, you know it has to have an x squared like this, and you know it's going to be some sort of U-shaped graph. Okay, so those are some of the big ideas we have so far. Quadratics involve an x squared, they're a degree 2 equation. If you calculate the second differences, they're always the exact same number. All right, so at this point, you might want to just pause the video and see if you can try the next one out on the page here. And then we'll go through it in a second here. All right, so let's go through the second one here. Similar sort of equation here, 2x squared. There's just this coefficient, this number that we're multiplying by at the front here. But I can already see, before I even do any work, I can already see, oh, it's an x squared. That's a quadratic. That's this new type of U-shaped function that we're looking at. But we'll do the same sort of idea here. Plug in our x's, figure out our table of values. So I start by plugging in my x is negative 3. And let's see here. So I get 2 times negative 3 squared. Following BEDMAS, I do that square first, right? So negative 3 squared gives me 9. 2 times 9, 18. Okay, and now I can fill in my chart. And once again, we go through, do that same thing. Now we plug in our negative 2. Right, doing that square first gives me 2 times 4 is 8. All right, and now I can start to plot these out, right? Negative 3 and 18, I've got my point here. Negative 2, 8, got my next point. Careful, the scale is a bit different here, right? Because this function has a lot larger y values. And I'll just keep doing the same thing, plug in negative 1, 0, fill in the rest of my chart. You can double check those answers, see if you got the same numbers. And that allowed me to plot it out. Okay, once again, it involves an x squared, and we did get this U shape again. So that's to be expected. That is our quadratic equation. It's always a U shape. Okay, let's say we didn't have the graph and we wanted to check if it was quadratic. All we had was this table of values. All right, well, we would use these first and second differences. Okay, once again, to get your first and second differences, always subtract from the bottom upwards. So subtracting upwards. 18 minus 8, 10. 8 minus 2, 6. 2 minus 0. 0 minus 2. 2 minus 8. 8 minus 18. Okay, once again, first differences, they're all different numbers. In this case, what have I figured out here? It's not linear. That's all I know so far. Okay, next one. So then we keep going. If it was all the same, we would just stop and we'd say, oh, it's linear. But it's not, so we need to keep going here. We'll do the same thing to get our second differences. 10 minus 6, 4, 6 minus 2, 2 minus negative 2, 2 plus 2. Right, careful with negatives here. Negative 2 minus negative 6, negative 2 plus 6. 4, 4. Okay, second differences are all the same. That tells you, oh, okay, I know that it is quadratic. And sure enough, when we graph it, yep, we get that U shape, which is our quadratic equation. Okay. So once again, you might want to pause it here and see if you can try the next two out, and then I'll quickly show the answers so you can double check those. All right, so here we are at the third one. Okay, so they've changed the equation a little bit, right? We have this negative out front and we're adding some numbers, but once again, it is still an x squared, which makes it a degree 2. It makes it a quadratic U-shaped graph. So once again, you went through and you plugged in your x values, right? Replacing the x with a -3, right? Following BADMAS, you did your exponent and then your multiplication stayed as a -9, adding. And you should have filled in your chart like that. And if you graphed it out, you'll get something that looks like that. Okay, in this case, it's still a U-shape. It's still a parabola. Looks a little bit different because it's flipped upside down. And what we might notice here is the only thing that's really, we added this 10, which has moved it up by 10, right? But the big difference is that negative out front. Right? And that's what's flipped it upside down. We say that it's a negative coefficient at the front. That makes it open downwards. If we go through and look at our differences, subtracting upwards, first differences are not the same. It's obviously not linear. We do it again, second differences. Okay, these are all the same, which is what we expect. That has to happen for a quadratic equation. So it is quadratic. And we also notice that they're negative here, which is kind of matching up with that coefficient. For the other ones, they were opening up and it was positive second differences. All right, now we'll go through and check your answers for the fourth one. This one was a little bit different. All right, so here we are at the fourth one. In this case, you have these two brackets that are multiplying together. But once again, if you expanded it out, right, let's see what we would get here. If you expanded it, you'd get, y equals x times x is, well, okay, we'll talk a little bit about expanding it in the future here. But in this case, we would get x plus, x times x is x squared plus some other stuff, right? And it doesn't really matter what that is right now. We do notice that it has an x times an x, which would have to give an x squared, which is a degree 2. It's a quadratic. So we can tell this, even though it looks a little bit different, it still involves that x squared. It is still a quadratic U-shaped graph. Once again, we'll go through here and fill in our table. Plug in the -3. Because of BADMAS, we need to do the brackets first. And then multiply. And I've gone through, that gave me my 8, and I've gone through and filled in that whole table again. Right, so you can double check your answers there, see if those are matching up. And if you graph it out there, once again, you'll get this nice U-shaped graph. We noticed this one was positive at the front, and there's nothing there. It's like a +1 out front. And yep, it opens upwards still. So that kind of matches out, right? Our second differences ended up all being the same for quadratic. They ended up being positive, which matched up with the opening upwards. So that's kind of a reoccurring pattern that we're noticing. Okay. So then I asked you guys, kind of what were some of these patterns that we figured out here? So if you want to, you can maybe grab some scrap paper and just kind of write down what were some of the patterns or big ideas that we found, and then we'll fill in this summary box here at the bottom. All right, let's see what we got here. All right, so what do we know about quadratics? We know that the equation involves an x squared. It has to. Sometimes it looks like x times x, but it's still an x squared in there. We call it a degree 2 equation. Okay, so yeah, sorry, here I'm saying, x times x, x squared. And we notice that, let's say you didn't have a graph, you only had the table of values, you could always go through and calculate your second differences, and those would always be the same if it's a quadratic. And the other thing we were noticing was the direction. Right? All right, so we'll see here. We noticed that we were getting this upwards U, like we say it opens upwards, if it was a positive out front. So we say a positive coefficient. So for example, the 2x squared graph, positive 2 out front, opens upwards. Second differences were all positive. And we noticed some of the graphs opens downwards, and that was the one I think it had a negative out front, a -2 or negative x squared, right? So they have a negative coefficient. So for example, -2x squared, that negative out front makes it open downwards like that. And those are the big ideas that we know about quadratics so far. So the whole point was this lesson is, just getting familiar with what is a quadratic. It's an y equals x squared graph. It involves an x squared. It looks like a u. The second differences are the same if you look at your table of values. And if there's a positive out front, it opens upwards. Say it's happy. And if it's a negative out front, it's a frown, it's a sad, it's opening down. Those are our big ideas so far.